Alright guys, so just a couple things to clean up, and then one new thing for this weekend for the homework tonight. First thing, we talked about the hypotenuse leg shortcut, so I just want to give you another example of that and just kind of clean that up and solidify it. So I apologize, I don't have my pen, so I'm going to have to type this up as we go, but hopefully that'll be alright for you guys. So, use the given information to show that triangle ABC is congruent to triangle ADC. You'll notice right off the bat that the given information tells us that they're right triangles. So that's the first thing that we need in order to prove this. So we always start off with let the given information be true, or in other words, let the diagram be given. And the next thing we need to do is figure out how we can approach this. We've got all of our information on the diagram. We know that D is a right angle and so is B, so we should be able to match those up. And again, we can look at that congruence statement and notice that both of those angles are in the middle, so those are corresponding angles. AD, does that correspond to AB? AD comes first and second, AB comes first and second, so those two are corresponding. And the last piece, hopefully these are kind of popping off the page to you at this point. But the last piece to this is that we've got this shared side right here in the middle, AC. So what we have is a scenario where we have A, S, S. So that's not a proof shortcut that works, but we have right triangles. And we talked about yesterday why that works. But if they are right triangles, then all we need are the hypotenuses to match up and one pair of corresponding legs to be congruent, and that's what we have here. So let's go ahead and go through the proof. And the technique that we're going to use is hypotenuse leg. So the first thing we need in order to do this is we need these triangles to be right triangles. So we just note, hey, it's given that these two triangles are right triangles. Therefore, we can use HL to prove congruence. Alright, and the important part of that, maybe that's a little long-winded, but the important part in that statement is that these two triangles, we want highlighter, these two triangles are right triangles. Alright, so that's the important part here. That's the first condition that needs to be present. So we're going to go ahead and go forward with our HL proof. So this is, we're going to give a hypotenuse argument and a leg argument. So the two hypotenuses must be congruent, and we know that we can say that because it's a shared side. So AC is a shared side. That's our hypotenuse argument. So that's the hypotenuse in each one of those. And then we need a leg argument. So that's just very simply given information. So we can come down here and just say AD is congruent to AB. And the reason that we can say that is that's given information. So I'm just going to slide my little congruent sign down here, and there's my argument. AD is congruent to AB. That's given information. So very simple HL proof. We first have to state that the two triangles are right triangles, and once we see that, we can just give the argument that the hypotenuses are congruent and one pair of corresponding legs is congruent. We always end with a therefore statement or a conclusion. So therefore, we know that triangle ABC is congruent to triangle ADC by HL shortcut. Let me finish this up, just put our symbols in here so you can see the whole thing kind of rolled out. Again, sorry I don't have my pen. Triangle ABC is congruent to triangle ADC. Maybe I'll just draw it in. All right, so there's the full HL proof. Just note the little things that we have to make sure that we include in this proof in order to do it correctly. All right, so the next thing that we want to take a look at is essentially I want to drive home the fact that just because you see right angles doesn't mean it's automatically an HL proof. And this is an example of that. What proof method should we use in order to prove that these two triangles are congruent? Well, if we go ahead and say, hey, I see right angles, so let's use HL, what we need in order to use that are two right triangles, which we have, one pair of corresponding legs, so PR matches up with PN. Those are both congruent. That's given information, but you need the hypotenuses to match up. And so in this case, we don't have congruent hypotenuses. We have parallel hypotenuses, which does not necessarily mean they are congruent. And here's a case in point. I can draw two segments that are parallel, but not necessarily congruent. All right, so these two are parallel but not congruent. So just because you see the parallel sign does not mean that they're congruent. Don't make that mistake as we go through. So to answer the question, what proof method should we use? Well, let's check out what information we have. Because these are parallel, we know we have two angles that match up. These are vertical angles, but it's given that they're congruent anyway. And then we have two sides that match up. So a bunch of different ways that we can go with this. The easiest way, in my mind, is to notice, hey, I've got parallel lines, so all those relationships exist with parallel lines. If I've got two parallel lines that are cut by a transversal, I've got angle measures that are going to be congruent. So this angle right here is going to be alternate interior with this angle right here. In other words, angle Q is congruent to angle M. I've also got this other set of angles. Angle R is congruent to angle N. And that's by that same reasoning. That's alternate interior. So there are a bunch of different ways that you can go about this. Angle, side is one way that you can go about it. You could also go angle, side, angle. Both of those arguments would work. HL in this case would not work because we can't prove that this hypotenuse is congruent to this hypotenuse. And that's really all we wanted to get through with this particular example. So just because you see right angles doesn't mean that it's automatically an HL proof. Step back and see what you have and make sure that you can fulfill all the necessary components, whether it's HL or ASA or whatever it is.